bada bing, bada boom. We're live. Okay. What? Come on. Single player, my little heaven. Come on, look. Okay, we're good. So, you may be wondering, what the hell is a helevetica? I don't know. Oh wait, let me mute my... I don't have a second monitor, but I do have a phone. Fun fact. I just have my screen open on my phone. Ugh! Alright. I had an idea. Behold, idea. If I pump it out at the same time, it should work. So let's clean all of this up. I'm starting over from scratch on part of this design. This side, basically speaking, works. Pearl. There you go. Last time, I figured out how to make sodium amalgamate and a acidic chlorine solution. Very pog. So this time, I'm gonna see if I can pump things out both ways. Like, I pump two things in, can I pump two things out? Just like... Because big if true, theoretically speaking, comically massive if true. Turn off mixer output. We turn in mixer input. Turn off mixer input. Turn on that. It gives that. Fantastic. Now, if I do this. No. Man. Alright. So, doesn't matter if I pump both ways. I can't do that. There has to be a way of cleanly removing substance. first we start with this. This will hold 1 bucket of material. I like having a system where we can... This will be very important. I need to get a comparator and test something. Cranking my column. Alright. Game's 1 thing of fluid. No reaction. Oh, the redstone signal has to be in through this side, eh? No. Ponder. What was it called again? Give me that name again. Threshold. So switch. Let me see. Right now, nothing. Now if I was to say pump in, aha, this is it. Put this like on any part of this thing. No, okay, so we can. Yeah, this should work. We're gonna want it sending signals to places. Well, I guess it's just one place, really. going for true automation here. Redstone. Alright, so we have this one, which will control the on switch. And this is an electrical component here, so you go down. But so when I do this, you won't do anything until you get a signal to your side, where in which it's not helping me at all. Very interesting. Not what I'm looking for. I need more advanced components here. So if I do this, and say 10 seconds. You will turn off after 10 seconds. Alright. Now that we have that, Really, we only need 5 seconds on this. So just as a test. That should pulse. And now you're on for a few seconds. This is where we attach here the zap control. Fantastic. So zap will be on. Yeah. So that's good. It fits. Fantastic. Right, perfect. Then we just need pump under control. Yeah, okay, here's what we'll do. We'll have it output to 1, flick a switch, that causes the valves to change, activate pump again, repeat. This is going to need a very long platform. Sequence controls. I'm just running through a sequence and it's gonna work. I'm a genius, that's why. Very humble too. Also, no, I'll keep it at 10. Alright. This will go to one of these, which will control the output. Fantastic, really. Then we go repeater, extender. Actually, we'll just go repeater, because it's only going to need a pulse, because we're going to do a sequence. Just to be sure. Which goes into output pump, so input, zap, output pump, switch output pump, wait a second, output pump. I mean, I could just loop it up and have it just go forever, question mark. We need to make some form of control. Redstone contact. Okay, fair enough. Not what I need. Let me just make sure I understand how the comparator works. So, comparator takes an input signal. I believe it's based on how powerful the signal is. Analog levers. That's 7, you're at 6. Yeah. Up. here's how we'll do it. In scenario 1, the analog, the fluid tank will say truthful and will stop it. Because we want to have a redstone signal. Get the call. Alternate scenario, and we can do this. We want to turn off the machine, so we would flip this, and just to be sure, proper pop. So wait 5 seconds. Okay, now I have to. Yeah, so this will turn it up. Because it has a slightly, I'm going to have it go straight from the holes, too thick. Turn on, zap, output. Red. We create 2 fluid tanks. Height. Round. Sequence here. Just for sure. I know, we just have a singular button to turn on the machine. How practical. Yeah. basically, if it's full. Yeah, when full, you'll send a signal on red. Await new redstone. Will turn. Reverse. Column. Shaft. Like so. Oh wait, no, wait, we want this going all the time. There'll be a little bit of fine tuning, all things considered, but we'll get there. Yeah. Redstone in. Wrench. Set to receive. Just to make sure. Redstone, pop. Wow. Yes, perfect. That output pump. Which is the fluid valve. And it's like red mode, yes. Boom, this causes the motor to run. We need to extend this. Stop one right there. Because we have the pump sequence. Pulse. Standard. Extend the pulse. control circuits, I hate them. Pump in. Well, we're going to have to move that just a little bit. We pump in stuff. After delay, it zaps the stuff for 10 seconds. After a delay, it pumps it out for 10 seconds. In 10 seconds, then it will immediately, just to make sure it doesn't like overlap, it will swap the valve, wherein which, after a delay, it will pump for 10 seconds. After a delay, it will swap it over. So pump, swap, pump, swap. So we'll be back in the room, and we'll be able to run the comparative that fluid tank's full, it's going to send out a signal of 14 minus 1, so 13, and this will send out a signal of 14 minus 2, so 12. So if this signal exists, which it will, this will turn up. Else, pump 1 will turn on again, filling it up. Then the zap will turn on. Alright. It's time to begin. Pump 1 activates. Filling. Oh wait, I probably said, okay, abort the sequence. Hold on. How did I forget this? We need the spout here so we only fill the thing with 100, right? Alright, let's move this back a little. pumps into there. Oh, we need the spout. You're saying that we're just going to pump these into 2 tanks. We can have these pumps always spinning. No, we can't. We need them to spin. Need 2 gears. Shaft. Here's how we'll do it. Yeah, I see. This will pump for 10 seconds into this. Then we need to activate. We could just do both pumps. For 10 seconds. Clutch, wood, redstone this, into this, and we'll just go double redstone here. Yep. Yeah, here's what we do. This empties the spout. Just give me like another little bit to work. halfway point. Since that will be empty, we then have the valve chains. We then, after a delay, repeat. We pump out. Then after a delay, I will womp, womp. Have the redstone going. Redstone will turn this pump on, which will empty the contents of that into whatever is the next thing. And then after a delay, delays here. Need the this goes back to scenario 1. When the tank is full, you will stop. Because you will send a signal. Redstone torch. There's nothing set to redstone torch, no. Zap engages. Good. After delay, pump 1 will engage. We can sort down the delays. Just give them liberal time. Oh, well, there's an issue. Stop the sequence. We were at the first of these, so wait a second now. Just have it go for like a second. Yeah. After the intended delay, the first pump will turn on, which will be the... Oh, wait. I do actually have to get the cogs out. Come on, come on, come on. Alright. Yeah, it's charging up. Now this time it will engage. Yes. Then this turns off, which swaps the valve. This one is now open. After the delay, we pump out the remaining chlorine solution into there. After a delay, the pump turns back on, filling this with chlorine solution. Then, after a delay, really I can shorten down these delays so much. Sequence begins again, swapping it back to sodium amalgam. Input pump is pumping. Yes. Yes. Yes, I've done it! I'm a god! I'm a god! Yeah. Creeper. Creeper, do you realize what I've done here? I've started the chemical revolution. It feels good to be a king, baby. Now, admittedly, I do want to shrink this down a little because I need to make a reaction vessel for some of these. We're so back, bros. I've done it. Before we soar into the delay on these, what I need to do is make a mercury recycling machine. Because with sodium, we can make sodium hydroxide, first off. because we're going to be reacting the sodium mixture of water, we could make paper pulp. So the solution must be 5 moles. So we would need to reduce the concentration, well, once this gets to 5 buckets, by 1/5 of its original volume for it to be useful. This one is a little different because ore processing. Two protons, so 2 moles of protons for that. Can't do that with gold because it's gold. 6 moles of proteins for iron. Actually, iron is like the hardest one to do here. To a comedic degree. I think we only need like 5 seconds on this. No. This here and just make sure everything's set to the correct setting. That feels it with the stuff. 5 seconds of stuff. it needs to be 10 seconds, actually. It needs to be 10 seconds. Fills up. It outputs. The outputting stops. Pumps it into. Oh no way! The system got messed up. We had a desequencing. What? Alright. Swap the valves. Very good. Okay. Yep. There we go. It's going fairly quick. We've done it. I've done it. Or at least part 1. Actually, this is like part 2 of this fucking nightmare. I mean, this is fine for now. The next part would be to react the sodium amalgamate. Well, not with that. Just with water, and then just centrifuge it off. Then we'll get the mercury back, which would be fantastic. Gives us also sodium hydroxide we can use. How would I gotta think about this a little. So, this is 1 molar sodium amalgam, which when reacted with water will produce the 1 molar, well yeah, actually, if I prepare 1 liter of water and mix it with this, will all the sodium dissolve into the water? Because if that's the case, that's convenient. This is just going to be a pain in the ass. I can so let me see something. Test. Can I make test tubes? Or is this solely a creative feature? I was doing some research the other day, figuring out how does one use this mod Fun fact. You don't. Well, yeah, you can make these. So, I wonder if this... So, in the last episode, if you're curious, I made this thing. Are we out of mercury? Why did everything break? Circuits. We'll stop it right here. Did everything break? Or okay, well, there's no sodium in there. Because that would turn, like, murky gray. Why did the tank stop filling correctly? Fills correctly. This system's got features. Just a couple. I don't know where 70... I don't know. That works. Then that works. It just broke for no inexplicable reason while I was looking at it. Whack. Let us look at... Let's just make two basic vats. I need to clear out my inventory of junk. Everything must go. We're going to need two vats. One vat just to mix sodium and mercury, and another vat to mix sodium and water, and one vat to mix, well, not mix, to evaporate bloody water, because we need to turn this chlorine solution into a higher concentrated solution. This is fine, basically. You know, when it finally fills up, I'll just, like, manually empty the last 25 millibuckets. That. Controller. Glass. So we need a 32 millibucket. So I'm just going to clean this up. Well, 32 liter vat, basically. Fun fact, since Minecraft uses meters, a block is technically just a liter. I didn't... No! Yeah. God damn it. Beep, beep. Fluid tanks. Let's try this again. Wow. And let's just make sure we have no upsets. I remember so many things. So little. Alright. Begin again. We're so bad. Yeah, so this thing just... Oh, I see the issue. Oh, I see the issue. Oh, okay. I ran out of brine. Because my, let me just leave that to fill up for a second. I need to breathe. Okay. I mean, I'm going to need, like, distilled water anyways. Let's just make it a little bigger. Brine throughput? Yeah. Well, first off, I can just expand the brine tank. Yeah. Put this back. Yeah, the system ain't running. Which in this case is actually a good thing. We restart. And then I focus on building a vat. Glass. The first vat's just gonna need to be a little big. Just objectively. And this, okay, the first tank is gonna be big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 4 by 4, that's 12. Then I need to make it tall. So 4 times 4 times 4. Da, 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 da. Length, width, height. 4 times 4 times 4 equal volume. Basic mathematics. A1 times B1 times C1 equals. Oh wait. A2, B2, C2. 64. Let's change this to 5. I want it to be a little bit more than... No, wrong. A little bit more than... Because we're going to add 32... 32 things of distilled water, 32 things of sodium amalgam, which will God, this is going to be a big one. So if you're curious why I'm making biggest fluid tank, is that I want to recycle the mercury. Because mercury, if I don't recycle, it becomes the most expensive thing here. But saying that I am capable of recycling mercury, it will be the least expensive thing. It's just that I need a very big tank. Because when mercury mixes with water, the video game says this is like a thing like milk. Like, you know when you have milk, right? And milk is a mixture. Or like, if you take mud and water and you mix it together, you see how like they mix together where you can't really separate them unless you like do like some sort of physical thing, like get a filter out, or in our case we're using a centrifuge. That's what it does. It makes like a muddy solution of mercury and water, which isn't how it works whatsoever. Alrighty. I need a wrench. The reason why I don't want it to be the exact volume is because if we pump in even one too many units with 0.1 millibucket, it will violently and comedically explode in my face. Oh yeah, we're getting there. The chlorine is just gonna be a bigger issue. I'm just gonna be real. Because, I'm just gonna need to reduce the chlorine's volume. With the chlorine solution's volume to make it useful. I need to electrolyze, well not electrolyze it, evaporate it off. It needs to be like 5 times more powerful than it, well not even 5 times, depend. Because I'm pretty sure, alright. We're gonna make a second tank. I'm just gonna make this one tall. Actually, I don't even need to make this one yet. I just want to. What I'm gonna do is I'm gonna break putting in mixture. Did we run out brine? No. Did we run out mercury? No. Why do these devolve into mixture? Pump. Cog. Pipe. Yeah. Let me see what happened to my precious mixture. Because I can see it happened. A little bit of mercury, guys. Do the thing. Yep. What if I scale it to be only like 8 buckets, right? We'll have turn the thing on. 8 buckets of chlorine. And way more buckets of this. Because I just want to practice right now, man. I just want to practice bloody mithril chain. Must be full. And that one is redstone, redstone. Go through the cycles once. It's fairly fast now, so that's not an issue. It's got mercury, it's got brine. This thing is finicky as hell. Who made this? Lol. There you go. We're just gonna need a lot of bloody... Well, not that much. I mean, kind of that much, but like... Not that much. Right. 7, 8, 9, 10. Alright, so it's not too much. We're just pushing the limit a little. Meh. Cog. Cog. Yes. Good idea there. Yeah, there you go. Now it should continue without a hitch. Parentheses. We'll wait for it to fill out. Actually, I could just pump all the distilled water in right now. Oh man. Glass. Gotta reset the thing. Wrench. You see, the reason why I'm doing this in creative mode is because it is comically finicky to set up. Like, not even funny finicky, it is just bad finicky. No. Let me get a tool that might help me out here. Alright. Clearing it out. I mean, there's nothing down here, so we should be fine. Nothing broke. Nothing broke. We just cleared up some room. Some tough, some copper. What is that? I don't know. Not important right now. Going through the cycle one last time. Come on. Well, maybe not one, 2 more times. Then I'll be able to say the machine works. Or it does not. This is 8 liters of distilled water. Yes. Put it all in. the machine's off. So that works. So we fill this with how much we're gonna do. So right now it's just water. Yep, that's water. Then we add some of this. Come on. Empty out. This solution heats up as this is an exothermic reaction, which is why we have the vent open. And that's all. Why are you heating up still? Stop it. Get some help. You done? Why is it getting warmer? There is nothing to generate heat. The sodium is the oxygen reacting with the hydroxide. No. Anathema. So, pipe. We're going to pipe it out into, behold, the centrifuge. Well, actually, we need pump, centrifuge, pump, pump. Pump, pump, pump. 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 Alright, now they're all working off the same kinetics. I just need a wrench. And let me get one of these just to make sure I know this thing works, right? Yeah. Mercury and sodium hydroxide. Well, that is not right. That's not what it's supposed to be. It did. Oh, no wonder. No way. I don't get it. first off, disconnect you. Pump this straight back in. I want to see how much it is what. Faster. This is just mercury. How? Huh? Hold up. Wait, you... Rar? Why are you getting warmer? So we should get the issue might have been the vent. Start up the machine again while I'm figuring this out, because I am so bloody confused right now. Disable this. Pump out the gunk. That's... Why does the volume increase? It's not supposed to do that. Just to make sure. This is the how does this before this, yeah. There. Yeah, you don't get hot. It's fluid centrifugation. Now it becomes mercury solution. There's still water in it. It's not supposed to be water. Where did it go? Alright. Theory. Some of the water evaporated during the whole procedure. Test. I'm gonna do it without a vent. Okay, we keep that because we're gonna need that. If the water didn't evaporate, empty, filled, with water, just water, good. And the machine is going to go through the last steps, pumping the last bit of chlorine solution into here before it switches back and turns off. Love this thing. Now, does this make a safety check? It's a little above pressure, not dangerously so. There's some hydrogen gas. How lovely. Makes enough sense. Now, in theory, repeat, in theory, when I pump this out, there will be no, it should perfectly split. At least I think it should perfectly split. If not, my hypothesis is wrong. I'm not an intellectual. Another test. We're making science here. Ponder. Chemistry. We boil it. Alright. Or distill any mixture. Alright. What's that one doing? Have a little fun. Alright. No. Maybe it needs to be like this. Oh! Water. Alright, here's what we do. We fill this. We do this. Let's just empty this out for now. And this will boil off and separate mercury and sodium hydroxide from water. Why is the sodium hydroxide still in the mercury? Is the game stupid? Could you empty just a little faster? You know, I'm just going to do this Texas style. And this water in here, this certified water, doesn't contain any sodium hydroxide. Because if it does contain sodium hydroxide, that means we've purified the thing, kind of. It is pure water. Okay. So let us get that into the tank just so I can see what's going on here. The sodium... This isn't how any of this works. Mercury doesn't have hydrogen. Mercury can't have a pH, right? Am I stupid? I was going to bribe my niece with a cake, but I mean it. I've achieved fucking Helvetica fucking situation. Fuck. Actually, yeah, that's pretty good. Yeah. How? I need some thinking music. I think. Where am I going wrong? So we do lose mercury. We start with 16.875 moles. Then we go down. We lose 0.3 moles of mercury. Where does it go? Ask your chemistry professor. If you don't want to ask your chemistry professor, I'll save you the time. No. Okay. What I was told was, this is why, you know how like every fish product has like a mercury label that says, warning, contains mercury? Yeah, the same process I was trying to do was used in real life, and that led to a little bit too much mercury escaping into the water. 0.3 moles isn't actually a lot. Mahjong Monday night. But that wasn't... Man. Mercury isn't supposed to have hydroxides in it, I'm pretty sure. Bruh. So, saying that removes some of the mercury, that means that sodium is something that has volume, since this solution doesn't change volume despite there being less moles of mercury, right? I tried boiling off the mercury one time, it just didn't work. Yeah, I'll think about this later. I got somewhere. This was Conley and Otsu, just 07. We had a Helvetica senario. Wait, yeah, I got OBS. It's